So we can have like a tutorial class, because definitely you need to do some exercise related to this one.
Quiz tu still open book ke apa doktor? Ke tak?
No, no. For nine, what call it?
Close
On
book.
9 July, quiz is closed book.
Okay, noted.
Because last time is on the spot. I give the question on the spot.
So both quiz part tu je lah masuk.
Same as the previous one. But quiz 2 related to orbital mechanics. It can be circular or elliptical to find period and velocity. The third quiz on the antenna look angle determination. You have to determine the elevation and azimuth. Okay, I think that's all for chapter 4. I go quickly on satellite subsystem. So I stop presenting for this topic. Share the slide for satellite subsystem. So I think this one, I don't need to use pen. So, okay, for satellite subsystem, we have two main segments. From here, we have Can you see my pointer? Oh, can you see my pointer?
Doktor tengah gerak ke sekarang? Tak nampak.
Tak nampak?
Tak.
Back to this mode. So I just use a mouse. Okay, we have space and ground segment. So even though if you refer to this one, space and segment, space refer to satellite, because refer to in space. But not all space segment are located in satellite. So you can see that there is a satellite control center where we have the main segment or subsystem called TTNC are located on the ground. Okay, so that means not all space segment are located on the satellite. So TTNC are located on the ground, which is on the satellite control center. Satellite control center actually owned by the owner of this satellite. Okay, so this not refer to every user has a TTNC. TTNC only available for satellite owner. So this TTNC is used to monitor the condition of the satellite. The user normally refer to the ground segment. So this refer to the ground segment, normally refer to the user. For the space segment, except for TTNC, all are located on the satellite. It's related to two main subsystem. One, we call it a communication subsystem. So communication subsystem is any device or equipment related to information that we transmit to satellite, and satellite need to transmit back to the ground. So any equipment, for example, antenna. So of course we need to have an antenna to receive and retransmit the signal. So that's why we say that the antenna is considered as communication subsystem or payload. Transponder refer to after antenna, we have power, low noise amplifier, we have a band pass filter, we have frequency converter. That's considered transponder. So any device that related to information signal. Whereas for bus subsystem, which is except TTNC are located on the space segment, is the subsystem required for satellite, but not dealing with the information signal. So this are related to how to satellite control in terms of orientation. Attitude refer to orientation in terms of the position of the satellite. So that's to determine the satellite in the right orbit, so that we have an orbit control system. And also power system, which is the main one is solar power system, and also we need to have battery. So that one is this power system is to power up the communication system, but it's not related directly with the information. So power system is considered a bus subsystem or platform. So the communication system is actually dealing directly with the information. So this related to space segment, payload and platform. For the ground segment, actually is for the user. So of course the user, depend on the user, it may consist of receiver only or both transmitter and receiver. So if we take an example for Astro, so we receive only. We didn't transmit. But if we take example of satellite mobile telephone, the ground segment, our handphone, satellite telephone consists of transmitter and receiver, and of course consists of antenna. So that's the overall satellite system. So we have segment, space segment and ground segment. So this slide just give an example of this one is payload. We have down converter, preamplifier, filter, high power amplifier. So these are related to payload. The rest are bus subsystem or platform. So we look at on the bus subsystem. We have three main bus subsystem: AOCS, attitude and orbit control system; TTNC or TTC&M. So this refer the same thing. and power system. So for attitude and orbit control system, attitude is this different with before this in the first part we say that altitude. So altitude is a position. So this refer to the height of a satellite. So this altitude. Attitude is refer to orientation of satellite. Okay. So AOCS is needed so that to make sure that the satellite in the correct position and in the stable condition. So this the condition where we need to have is OCS. So orbit insertion mean this the earlier process. The earlier process to put satellite in the correct position. So this one is after the process of launching. So once the satellite in place in the operation, so we have two process or tasks: orbit maintenance and fine pointing. So this after the satellite in operation. So this the orbit insertion is early stage. So we can say that we have two main tasks. Attitude control system actually is referred to how to make a satellite in stable condition, and then the right pointing. So orbit control system to make sure that satellite in the correct orbit in terms of height and in terms of what I call it, the orbit plane. All right. So because of in the space, we know that in the space gravitational, we have not only gravitational force due to Earth, we also have a gravitational force due to other planet, for example, moon and sun. Okay, so that's why we need to have AOCS to make sure that the satellite in a stable position or condition. So in order to make it the satellite in stable condition, where it in the space we have weightless, that means it's not as really zero we call it in terms of weight, 0 kilogram and so on, but it's lower weight. And the for example, if you're on the ground, your weight is around 50 kilogram, but when you are 36,000 above the ground, your weight become 1 kilo, for example, something like that. So that's we call it weightless. So So for this condition, in order to make it the satellite in stable condition, the body of satellite need to be rotated. So I think in the Facebook, in the YouTube, you can see that there is an experimental where they tie what I call it like bicycle tire or wheel with the rope. If they didn't spin the wheel, the wheel is not standing. But when they rotate the wheel and then they hold the rope, the wheel is standing. So that's the relationship between stability with the rotating. Same thing for satellite. To make it the satellite stable, we need to rotate the satellite body. So that's why there is a satellite something like this. In order to have a satellite stable in the space, so this body, this the main part of the satellite body must be rotating. But of course, the satellite antenna cannot be rotating. So there is like a gear between the rotating part with this antenna part. So antenna part must be stay because it's pointing to the ground earth station antenna. So this the antenna part cannot be rotating. The rotating part is only the satellite body. So I hope you understand. So this spinner satellite, another type of satellite, we call it three-axis stabilized satellite, refer to there is a three momentum wheel that are rotating in order to give a stabilize the satellite. So this rotating part, we call it momentum wheel, and then three axis refer to this momentum wheel rotating in three different axes. Okay, so that's two type of satellite, and then to make it stable, we need to have a rotating part. For this one, obvious, the body of the satellite is rotating. But for this type of satellite, we have three momentum wheel rotating in order to stabilize the satellite. So if let's say the satellite is drifting, moving from the original or the correct position, so we need to on the rocket motor on the satellite. So to move a satellite in the back to the correct position. So that's why we say that in early in my lecture, we say that we bring the fuel. So the fuel actually is for rocket motor. So this we use to on the rocket motors to move satellite back to the correct position. So we have two type of rocket motor. One is using fuel, so this type of fuel, and electronic or electric rocket motor. We use high voltage. So for the if the satellite drifting So I did mention on the orbit plane. So this refer to supposed to be the correct orbit plane is equatorial plane, but somehow the satellite drifting to different orbital plane. So there is a inclined orbit plane. So we need to move back this satellite, the circle one, to the correct position. So this related to orbit control system. So where we have a different orbital plane. So this process we call it station keeping. So since the satellite can drift into two directions, either north or south, or east or west. So we have two types of station keeping: north-south keeping and east-west keeping. So this based on theoretical east-west keeping require small maneuver. I mean, we require a small amount of fuel to on the rocket motor. But for the north-south keeping, we require more fuel so that the satellite can move to the correct position. Next one, TTC and M. The first two T refer to telemetry tracking. Telemetry tracking command. M monitoring actually is the same thing. So we normally use TT and C. First T refer to telemetry. Second T is tracking. C is command. Telemetry involve the data transmission of data from satellite to the ground. So on the satellite, we put many sensors to monitor the condition of the satellite. So all the information gathered from sensors on satellite will be transmitted to the satellite control center. So that's we call it telemetry. Information from what I call it sensors on satellite to the Earth station, to the satellite control center. So we call it telemetry. So tracking involve the information that we gather. We process the information in order to monitor the condition and the position, the orientation of the satellite. So that's referred to tracking based on telemetry data. And then command, if let's say if we detect any what I call it, for example, the drifting of the position, so we send a command to satellite, for example, to on the rocket motor. So that's the command. Involves sending command from satellite control center to satellite to control its position. So that's referred to TTC. So this, as I mentioned, telemetry, we have many sensors to measure pressure, voltage, current, temperature, and so on. Tracking, we process the telemetry data to determine the satellite position, altitude, and other parameter. So command, we send command information to satellite. So power system, the main one, as you see from the satellite picture, for this spinner satellite, so the body of the satellite covered by solar panel. And then for this one, they have a solar sail in flat solar sail. So this, as we know, the solar panel will convert from sunlight to electrical energy. Then this electrical energy need to power up all the communication system and electronic circuit. But due to there is a eclipse event in 1 year, there are 2 events where the Earth prevent the sunlight from reaching to satellite. So that means we cannot use solar panel to generate electricity due to the Earth prevent sunlight from the sun to reach the satellite. So during this eclipse event, we need to use a battery. So that's why beside solar panel, we need to have battery on the satellite. So this just what I call it, information related to available energy from the sun. But as we know that the efficiency of solar panel to convert sun energy to electricity about up to 15% only. So this related to battery. This when we require battery, as I mentioned, during eclipse and also during launching. Because during launching, we need to communicate with the satellite. But during that launching, we cannot. The solar panel is still not been placed yet. So we need to have a battery. So for communication subsystem, we require antenna and transponder. So this slide shows the received signal from uplink is about 10 to 100 picowatt. So we need to re-amplify so that the output signal should be 10 to 100 watt. So we require almost 120 dB power gain. And then the signal that we receive normally a wideband, 0.5 gigahertz up to 1.5 gigahertz. So in order to increase this high gain for the wideband is not possible, because it's very challenging to have a high gain for wideband signal. So we need to split this wideband to subband. So that's why we have something. There is, I think, not in the. So we have. I think the tomorrow one did put this diagram showing that we need to split from wideband to several subband. So So we split, let's say 0.5 gigahertz into several subband. So subband, that means we have a different frequency. So we use a different amplifier. So that means it's not we use a single amplifier. They depend on number of subband. So we require a series of amplifier. So these two type of payload or transponder, regenerative and onboard processing transponder. Sorry. So I think regenerative transponder onboard. This one actually is refer to the same thing. So this is same category. The second category is frequency translation transponder. So this frequency translation means we change the carrier frequency only. For example, here we down convert from 6 gigahertz to 4 gigahertz. So that's we call it frequency translation transponder. Whereas for regenerative transponder and onboard processing transponder, we do have a demodulation process. We have a demodulation process. That means we extract back from original information signal from carrier signal, and then we remodulate before we retransmit. So that's, we call it onboard processing or regenerative transponder. This one require if you want to have very high quality of signal. Whereas for frequency translation, something like this, we didn't do demodulation. We just change the carrier frequency. So this for C-band for 6 gigahertz to 4 gigahertz. So this diagram for onboard processing transponder, we have demodulation circuit here, and then we need to modulator to modulate again. So for satellite antenna, we have several type of antenna. We have a global beam, spot beam, multi-beam, on orthogonally polarized beam. So that means same zone, same area, but two different polarization. Spot beam normally small area and different coverage area. Global, we have only one beam with a wider beamwidth. The difference between this consider spot beam as well, but this from single antenna. So this single antenna can produce a multi-beam. So this we use if we have two spot beam, that means we need to use two antenna. So this is the one that I mentioned in limb budget that depend on this, we call it contour, footprint. So if our Earth station located in the center, so there is no off-axis loss. So because the the both antenna on satellite and earth station are inline. So, but if our earth station located not in the center, so there are both antenna is not 100% inline. So some offside. So then we have for each zone we have 1 dB loss. So this 1 dB, 2 dB loss, 3 dB, and so on. So this another type of coverage. So this give you, for example, in the center we have the gain will be, antenna gain will be 58. So if you are on the other zone, the gain will be reduced. So this in the gain value, but this one is in terms of how many dB reduced. So that the different. So this in terms of station technology, not all station has a tracking. For example, in Astro, we don't have tracking. For GEO satellite, we don't have tracking. So this refer to ground segment, refer to user. User can be fixed or can be mobile. So for mobile, can be aeroplane, can be in the vehicle, ship, or pedestrian. So that's all for satellite subsystem. So if you have any question, you may ask me on 9 July. So that's all for today.
Doctor,
Yes.
before we end, can I ask some tips or hints for final exam?
I will confirm with Dr. Marwan or coordinator, Dr. Omar, if I can list down question number 1 related to which topic and so on.
Hopefully boleh bagi sebab macam
Uh,
a bit harder sikit lah, wireless.
So I will consult with Dr. Omar. Then if he allow, then I will give some
Okay, Doctor.
hint.
Thanks for your consideration.
Okay. Okay. I hope you learn something. So you go through the note. If you have any question, then you can ask me next week, right? Next week on Sunday.
Okay, thank you so much, Doctor.
Okay.
Have a nice day.
Okay, thank you.